Okay, today we're going to do 5.3 day 2 reference angles, and we'll be using reference angles to simplify finding sine, cosine, and tangent of larger angles. Okay? So here, using the reference angles is going to make finding the value of trig functions greater than 90 degrees a lot easier. So yesterday, we talked about these ones on the bottom here, the quadrantal angles, 0/360, 90, 180, and 270. Okay? The quadrantal angles are special. But today we're not going to talk about the quadrantal angles. This is something you need to keep in mind for your quiz tomorrow. Today we're going to talk about our special angles, our 30-degree angle, our 45-degree angle, and our 60-degree angle. These are found in the first quadrant of our unit circle. Okay? Realistically, once we finish our unit circle completed with everything in it, all you're really going to have to know is your first quadrant, and then you just extend from your first quadrant. Okay? So get this table written down right here. The special right triangles and trig functions, the special angles. It's very important that you have these memorized. Now, if you remember a couple lessons ago, we did something called cofunctions, where we said that, for example, the sine of theta equaled the cosine of 90 minus theta. Okay? So let's look at our first column here, 30 degrees. What is the cofunction for 30 degrees? What's 90 minus 30? 60. So the cofunction for the sine of 30 is the cosine of 60. The sine of 60, its cofunction is the cosine of 30. And then your tangents between the two just reciprocate. 45 degrees is easy to memorize. Okay? Remember, it's always sine over cosine to get tangent. And so sine and cosine are the same because a 45, 45, 90 right triangle is isosceles. So the official definition of a reference angle, okay, hold off on writing this down, please. The official definition of a reference angle, let theta be a non-acute angle in standard position that lies in a quadrant, any quadrant, doesn't matter. Its reference angle is a positive acute angle, and we call it theta prime, formed by the terminal side of theta and the x-axis. Okay, so don't worry about the second box for a second, but in summary, what does that mean? That means that your reference angle is the angle between the terminal side and the closest x-axis. Okay, so for example, here I have some angle theta. So with the terminal side of theta, where's the nearest x-axis? Right here at 180 degrees. So this distance from terminal side to x-axis is what we refer to as theta prime. And it works in the other quadrants too. Here I have an angle in the fourth quadrant. And my angle that's in the fourth quadrant goes from here to there. So that's my theta. So where's theta prime? Well, where's the distance from this terminal side to the closest x-axis? It's right there.
Say that angle was in quadrant 3.
Okay, let's look at an angle in quadrant 3. You hear what you're saying? So there's theta, right? So where's the closest x-axis? We're going to backtrack to 180. So that means that from here to here is theta prime. Okay? And while technically speaking, going from here backwards to the axis would be negative, we're not going to think about our reference angles like that. We're going to think about our reference angles as positive. And then when we assign our cosine, sine, tangent values to the angle, that's when we're going to think about, okay, what quadrant are we in, and is tangent positive in this quadrant, or is tangent negative in this quadrant? Other questions? All right, so let's start by practicing finding our reference angles. We're going to draw a sketch of the angle to help us do that. So we're going to start with 120 degrees. In which quadrant would I find 120 degrees? It's in quadrant 2. We'll just estimate where that is for now. So there's my theta. All right, so where would I find my reference angle? It's going to be in between the terminal side and 180. Well, how many degrees are between the terminal side for 120 and 180? 60. So that means that your theta prime, or your reference angle, is 60 degrees. Now, nobody has the sine, cosine, and tangent for 120 degrees memorized, but you should have the sine, cosine, and tangent for 60 degrees memorized. So that's what we're going to be using the reference angles for. Now, in quadrant 2, which is where we find 120 degrees, which of my 3 main trig functions is positive in quadrant 2? Sine. A smart trig class, so sine. Okay? All right, 4 pi over 3. Draw a little sketch of 4 pi over 3. And in which quadrant do I find 4 pi over 3? Jesse? It's in quadrant 3. Good. How far into quadrant 3 is it? 1/3. 1/3 pi. Okay? So theta prime is the distance between 180 and the terminal side. Well, here you see the distance between 180, aka 1 pi. Well, 4/3 is 1 and 1/3 pi, so it's 1/3 pi past 180. So that makes that your reference angle. So your reference angle here, theta prime, is pi over 3. Because pi over 3 is the distance between 180 and my terminal side. Now, pi over 3 is equivalent to 60 degrees. Okay? Now, in quadrant 3, which of my trig functions is positive? Tangent. Good. Okay. I want you guys to do the third one on your own. Which direction do negative angles go in? They go in a clockwise direction. So moving in a clockwise direction from 0, where would I draw negative 120 degrees? Quadrant 3. So there's your theta, negative 120 degrees. So now where do I find my reference angle? I find my reference angle, again, right here. So what is the value of this theta prime between technically this negative 120 and negative 180? Okay, so, but when we talk about reference angles, we want to talk about them as positives. So we just call it positive 60. All right, 7 pi over 6. It's going to be in the third quadrant. Awesome. How far into the third quadrant is it? Okay, it is 30, but if you start with radians, you want to end in radians. So here it is pi over 6 radians. So that's your reference angle, your theta prime. Questions on reference angles?
So I don't get how do you find it? How do you know that's 60 and there's pi over 6?
This isn't 60.
No, I'm talking about like other ones. Like, I don't get how
Well, if from here to here is 120 degrees, how many more degrees does it take to get to my x-axis? 60. Here, when I graph 7 pi over 6, well, 180 degrees is 1, right? So it's 6 pi over 6. So how much more is 7 pi over 6 than 6 pi over 6? 1 pi over 6. Okay? Does that make it a little clearer? Okay.
So is reference theta and the reference angle and what is called the theta with the
Theta prime?
theta prime are the same thing?
Theta prime is the name of our reference angle, yes.
Oh, okay.
That's what we call it. Questions? All right. So what do you notice about our next set of examples? They pass 360 degrees. All right, so 405 degrees is 360 plus another 45. Okay, remember this starts here, goes all the way around and past. So when we talk about our reference angle, the nearest x-axis is this area here. This is going to be theta prime. So what does theta prime equal? 45, perfect. All right, 7 pi over 3.
How do you get pi over 4? This one.
The first one? 45 degrees? Oh, if we're given degrees, we stay in degrees. If we're given radians, we stay in radians. Of course. All right, so theta equals 7 pi over 3. Sketch that out. So in terms of thirds, okay, because we have thirds here, how many pi up top is one full rotation in terms of thirds? 6. So this is one full rotation plus another pi over 3. Good. Okay. So that means that our reference angle is this area here. And what is our reference angle equal to? Pi over 3, that extra that we graphed. Okay, 19 pi over 6. So now we're working with sixths. In terms of one full rotation in sixths, how many pi is that? 12 pi over 6. Okay, so how many full rotations do I have?
That was going to be the best part.
Okay, so 19 pi over 6 is one full rotation. plus how much?
7.
7 pi over 6. So we have one full rotation. So one full rotation is 12 pi over 6. Half of a rotation is 6 pi over 6. That's 18. And then we'd have to go one more pi over 6. So again, our reference angle is this little area in here. That's our theta prime. So in radians, it equals pi over 6. I don't want you guys to do 580 on your own. So for 580 degrees, we have one full rotation, that's 360, plus another plus another 220. Where do we find 220? In our third quadrant. Okay. So here we kind of have a funky situation because this isn't truly a reference angle, because how many degrees is it from 220 back to 180? 40. So that's not really useful. I just kind of made that up, and I made up a bad one. Okay. When you're asked to find a value given reference angles, your reference angle is always going to be either 30, 45, or 60, or of course the radian equivalent to it. Questions? Alrighty. So now how do we use this? So when we find our reference angle, our 30, 45, or 60, we already have our sine, cosine, and tangent values memorized. So all we do is we take that sine, cosine, tangent value that we have memorized and give it either a positive sign or a negative sign based on what quadrant we're lying in. Okay, so again, if you're in quadrant 1, all of them are positive. Thinking just of our three main ones, not the reciprocal relationships. In quadrant 2, your sine is positive. Quadrant 3, your tangent's positive. In quadrant 4, just the cosine is positive, because you guys are a smart trig class, because I love you. So are we all set now in the relationship of what function is positive in which quadrant? Okay, so now how are we going to use our reference angles to evaluate our trig functions? So the first thing we're going to do is find the associated reference angle, theta prime. So then we're going to combine those two pieces of information. What quadrant are we in, and what is theta prime, to assign the appropriate value to my sine, cosine, tangent function. So let's look at how that works. So first of all, we have the sine of 300 degrees. I'm going to draw this one out. This is the last one I'm going to draw out, though. In which quadrant do I find 300 degrees? I find this in quadrant 4. Now I'm asked to find the sine. In quadrant 4, is sine positive or negative? It's negative. All right, what is theta prime? Well, 300 degrees is here. So how far do I have to go to get back up to 360? 60. So theta prime is 60 degrees. So we're asked to find the sine. What's the sine of 60? Square root of 3 over 2. But in quadrant 4, it's negative. So that means that the sine of 300 degrees is the negative sine of 60. Well, the sine of 60 is the square root of 3 over 2. Questions? Because it's in quadrant 4. All smart trig class means that only cosine is positive in that quadrant. All right, the secant of negative 17 over 4. How many full rotations do I have in that? I have 2 full rotations plus a little bit. How much extra do I have and in which direction? It's in the 4th quadrant. How far in the 4th quadrant?
45 degrees.
So we have, except we want that in radians. So we have negative 8, negative 16, negative 17. So our reference angle, we only want 1 pi over 4 passed. Now, that's in the quadrant 4. In quadrant 4, is secant positive or negative? Well, secant is a reciprocal function for which of my main 3? Cosine. And in quadrant 4, is cosine positive or negative? It's positive. So if cosine's positive, secant is positive. So that means that the secant of negative 17 pi over 4 is the positive secant of pi over 4. All right, we'll look at your secant is cosine. So cosine of pi over 4 is the square root of 2 over 2. So we have to reciprocate the square root of 2 over 2 to get the secant. So what does that equal? Square root of 2. You multiply both sides by square root of 2, so on top you get 2 square roots of 2, and on the bottom you get 2, and the 2's cancel.
Why did you start out on the y-axis instead of the x-axis with your circle?
I didn't. I just didn't pick it up because I drew over it.
Oh, okay.
See, when I had originally started this, it was up there.
Oh, I see.
All right, so the tangent of 5 pi over 4. 5 pi over 4 is in which quadrant? Quadrant 3. And quadrant 3 is tangent positive or negative? It's positive. What is the reference angle for 5 pi over 4? It's going to be pi over 4. So when we take the tangent of 5 pi over 4, it's going to equal the positive tangent of pi over 4. Well, the tangent of pi over 4 is 1. So the tangent of 5 pi over 4 is 1. All right, in our last example, we have the cosine of 17 pi over 6. So we need to determine which quadrant 17 pi over 6 is. It's in the 2nd quadrant. In the 2nd quadrant, is cosine positive or negative? Smart. Well, one full rotation is how many sixths? 12. So that means this is one full rotation plus another 5. So 5 pi over 6 is, you were right, in quadrant 2. All right, so now what is my reference angle? It's pi over 6. Because 5 pi over 6 is the distance that it goes past that one full rotation. Remember, your reference angle is the distance between your terminal side and the x-axis. So the distance between the terminal side and the x-axis would be that extra pi over 6 that it would drop. All right, so that means that the cosine of 17 pi over 6 is the negative cosine of pi over 6. Well, it's the negative cosine of pi over 6. Negative square root of 3 over 2. And that's why it's so important that you have this table right here memorized. Okay? Because finding reference angles, it was kind of time consuming for us today to find reference angles, but that's just because it was our first go at it. The more you practice these, the quicker finding your reference angle is going to be, and then once you have these memorized, it's really, really super quick to go angle, reference angle, answer.
So will our answer be one of those 9 or reciprocal?
Your answer is always going to be one of these 9, or it's reciprocal. Absolutely.
Okay, well,